With Ajanako, today we shall be discussing surds. Surds are irrational numbers, meaning numbers when simplified further gives unending decimal places. Examples of such numbers are 1 over 3 pi, which is 22 over 7. We have many more of that. Then we also have some special set of irrational numbers which are in root forms, like root 2, root 3, root 5, root 6. They also give unending decimal places. This kind of irrational numbers seems to be the majority of the irrational numbers, and we call them surds. So what we're about to discuss today is how to perform operations on them. Of course, there are rules guiding them. The first of which is, if you have root A times root B, you can create a bigger root and join and multiply A and B together. If you have root A divided by root B, create a bigger one, then divide A and B inside of it. Then if you have root A raised to power 2, meaning a perfect square, you have a rational number. Also, do note that the square root of A plus or minus root B is not the same as root A plus or minus B, in a sense that if you were to be given this root 9 plus root 4, if I should evaluate this directly, this should give me 3 plus 2, which is equal to 5. Now, if you were to view it in this way, as root 9 plus 4, if you do this now, this will give me root 13. And you can see they are not the same in any way. So that's the reason we said they are not the same in any form, both in the case of minus and subtraction. So to understand this better, let's talk about whole surds and basic surds, where we shall be applying the rules a bit. Now, let's talk about whole surds. The whole surds are surds that are those that are in the root. You see them inside the root. They don't have any attachment outside. Now, this is an example. This is an example of a whole surd. And as a whole surd, you can reduce a whole surd to its basic form. How do you do that? You extract the maximum perfect square from it, which is the maximum perfect square in 8 is 4. And that's going to be 4 times 2. Now, by further simplification, this will give me root 4 times root 2 from the first law. So, by so doing, simplifying further, this will give me 2 times root 2, which means this is 2 root 2. So, the basic form of root 8 is 2 root 2. That of root 12 will be, the maximum perfect square there too is what? 4. So, this is root 4 times root 3, and this will give me 2 root 3. So the basic form of root 12 is 2 root 3. That of 75, the maximum perfect square is 25, so that's 25 times 3, and this will give me 5 root 3. So that's how to convert them, because you can find the square root of 25, you can find the square root of 3. So the square root of 25 is 5. That of 3, we can find it, just drop it, attach it to it. So that's how we do that. Now, what about we converting back to from basic form to whole form? What do we do about that? In doing that, it's also quite very easy. So this is just the reverse case of the former. How do we go about this? This becomes 5 times root 3. And this is the same thing as which number has the root of 5, and that is 25. So if I can put that in its roots, that's 25, root 25, which is 5, times root 3. And this will give me root, from the first rule there, this will give me root 25 times 3, which is equal to root 75. Likewise, in this case, this can be written as 7 times root 2, and this is the same thing as root 49 times root 2, and this is equal to root 98. That's the whole form of 7 root 2. The whole form of 11 root 2 will give me 11 times root 2, and the square root of 121 will give me 11 times the square root of what? 2, and this will give me the root of 242. Right now, let's discuss common surds. What are common surds? Given root 4 root 2, 11 root 2, root 3, 3 root 3. If you notice, the values we gotten are the rational part of these numbers look alike in the case of root 4 root 2 and 11 root 2. So they have root 2 at their irrational parts. So which make them what? Common surd. They look alike. So likewise, root 3 and 3 root 3 also look alike. So we call them common surds. So the idea of common surd makes it easier for us to perform addition and subtraction, even multiplication on surds. For an instance, supposing you are given root 32 plus root 3 root 8. So the first thing you have to do is put them in their basic form. By so doing, this will give me root 16 times 2 plus 3. I can have 4 here too. That's 4 times 2. And this will give me, when I simplify this will give me 4 root 2 plus 3 times this will give me 2. The remaining root 2 here, then drop it down. Now, further simplification, this will give me 4 root 2 plus 6 root 2. And when you simplify that further, you should get 10 root 2. Also, we can take another one. Supposing you are given, number 2, supposing you are given 3 root 48 minus root 75 plus 2 root 12. Let's manage it here. Now, from here, I can extract the maximum perfect square from this. This will give me 3 into 3 root 16 times 3 minus the square root of 25 times 3 plus 2 into the root 4 times 3. Now, when I extract, after extracting the maximum perfect square, now simplifying further, the square root of 16 is 4 times root 3 minus the square root of 25 is 5 root 3 plus 2, the square root of 4 is 2 root 3. So this will give me 12 root 3 minus 5 root 3 plus 4 root 3. And then obviously 12 root 3 minus 5 root 3 will give me 7 root 3. 7 root 3 plus 4 root 3 should give me 11 root 3. So that will be all for now. Join me in the next class to discuss the remaining part of surds. Thanks for watching. Please don't forget to hit the subscription button if you haven't yet. Share our video. Of course, hit on the like button. Thanks for watching. Bye for now.